Hello class, this is a video tutorial on the continuation of approximating areas under a function, part 2. In the previous video, we actually saw how we could find the exact area of areas the exact area below a function using regular formula that we know of triangles, rectangles, circles, and etc. However, it's sometimes impossible to do that. So when calculating the area of irregular shapes or composite shapes, the process involves breaking up the shape into smaller regular shapes that we have formulas of. And I've demonstrated here 3 of them: rectangle, 2 rectangles, a rectangle and a circle, and a square and a half circle. A similar approach can be applied to functions using rectangles of same height but varying length. We'll get more into that as we go on. Now, this would only be an approximation, and how close of an approximation is dependent on 2 factors: the number of iterations. An iteration means how many times we break up the shape, and whether it is over or underestimated. Right, so here's an example of one iteration. So let's say we want to find the area below the function of x squared from 0 to 4. So I've made a graph here of the function x squared from 0 all the way to 4. Now I want you to, so normally we think of height as going upwards, but for these, I want us to think of the height as going along the x-axis, and the length of these is some function of the x value that we pick. So let's take a look at one iteration of this. So this is an underestimation. Okay, so our height here is 4. And our height is taken at this left point here. So our estimated area of this is, well, that's 0. Now if we do the same thing, so our height is from 0 to 4. So our height is still the same, 4 times, but our length this time is going to be taken on the right hand side of the rectangle. So in this case, it's going to be f of 4. F of 4 here, f of 4 is going to be 4 squared, which is 16. And 4 times 16 is 40, plus 24 is 64 units squared. So from one iteration, the area below this area here, the estimation that we have, the area must be greater than 0, but less than 64. Obviously, this is an over-exaggeration, but let's take a look at what happens if we do 2 iterations. So we're going to break up this curve into 2 rectangles. Let's take a look. So here's an underestimation of 2 iterations. And once again, we're taking the left-hand side for the underestimation of our height. So now let's consider, what is our height this time? Well, if we're going to take from 0 to 4, it's normally 4 units, but we're going to break it up into 2 even rectangles. So this first height is 2 times the length up here is going to be 0. So it's going to be 0. And this second rectangle, the height again is going to be 2 times the height here is f of 2. 2 squared is 4. So it's 8. So the total for this is 8 units. So an underestimation is 8. Now let's take a look at an overestimation. We have area 1, this rectangle here. Our height is 2, so from 0 to 2, that's our height. And our length is going to be f of 2, which is 4, so 2 times 4 is 8. And then for our second rectangle, once again, our height is 2. From 2 till 4 is 2 units across. And f of 4 is 16 times 16. That's 32. And now 8 plus 32 is 40. So now our estimated area is between, so it must be less than 32, but it must be greater than 8. As you can see, we're getting closer and closer to what the actual area might be. Let's do this one more time for 4 iterations. As you can see, we're taking the height from 0 to 4, and we're breaking it up into 4 different heights. So in this case, our height for each of these is going to be 1. So our height is 1 for all of them, times. For this first rectangle, it has a length of 0. That's 0. For this second, area 2, the length of this is f of 1, so 1 squared is 1. This third rectangle, the height of this is going to be f of 2, which is 4. That's 4. And the length of this fourth area is f of 3, which is 9. So the total of all of this, 0 plus 1 plus 4 plus 9, is going to be 14 unit squared. And that's an underestimation. If we do this one more time, so the height for this, for all of these, are going to be 1 times, and now the height for the area 1, that's f of 1, that's 1. The height of area 2 is that height there. F of 2 is 4, so that's going to be 4. The height of, the length of area 3 is f of 3, so that's going to be times 9. And lastly, the length of area 4 is f of 4, which was 16. That's going to be 16. Adding all of these together, so our total is going to be, that's 10 plus 20, that's 30 units squared. So our new estimation for this, so our area, is going to be between 30 units and greater than 14 units. As you can see, we're getting closer and closer to a better estimation and approximation of the area below the curve, because ultimately what we are looking for is this area here. But so far, the only tools that we have are approximations using rectangles, either underestimation or an overestimation to give us a range of answers. And we can repeat this more and more times. I'm not going to be doing it. This is 11 iterations. So here's an underestimation of 11 iterations. There are 11 rectangles there. And here's an overestimation of 11 rectangles. Right? To calculate the exact area of this, we can use infinite iterations. And we'll get into this much later. As you can see, the rectangles are so small that they're actually, it's actually the curve itself. But we'll get into the theory of that in future. So I hope that gave you an insight into using rectangles to approximate areas under a function. Hope to see you in the next video. Best of luck.